So it is a great pleasure and honor to introduce this session on cold molecules. I have known Alex exactly for 40 years. I saw him the first time in '68, where he was the star at a conference in Belfast. It was my first conference, and I was just starting after the birth of my first son, who is exactly day to day 40 years younger. And on many subjects, among which cold molecules and ultra-cold collisions, we have seen that Alex is far ahead. And I am very impressed to see how his work is well integrated within a tradition. And I particularly appreciated his presence and commitment, in particular at scientific conferences, but more generally, his commitment to organize the scientific community. And when the cold molecule networks were organized, Alex was extremely supportive. And so I am particularly grateful, as you will see. So this is a picture taken in Telluride. We are climbing a mountain, and Alex is looking far ahead. Yesterday we saw in detail, and so I shall only summarize, that there indeed has been a long tradition of work on long-range forces. It started in Belfast with brilliant mathematical developments on perturbation theory. And then, as we saw yesterday, there were many applications to calculation of long-range coefficients. And these long-range coefficients are crucial for the treatment of slow collisions and ultra-cold collisions. Many papers were recalled yesterday. I won't go back. I want to insist something that was particularly important for us was the work of Chris Bottcher and Alex Dalgarno on model potential calculations. Away from ad hoc semi-empirical treatments where people were fitting anything on experimental data, they developed a rigorous model where a Rydberg atom is treated as one electron in the field of a polarizable core, a Rydberg molecules, single electron Rydberg molecule, one electron in the field of two polarizable cores, and then cross-polarization forces are crucial. When I was preparing this talk, I decided to add two quotations because we were very excited by this work, and Ron McCarroll suggested that we work on that. It was the PhD thesis of Pierre Valiron. Ron McCarroll was supervisor and I was collaborating, and it was one of the best collaborations I ever had. Unfortunately, Pierre Valiron died last week, and so I thought that it was valuable to remember the two important papers that he has done exactly on the line of the work of Bottcher and Dalgarno, and how happy we both were when we went to present the results to Alex, and he said, "I did not believe that you could reach this accuracy." So we were very proud. And so when the cold atom collision field has opened, immediately the group in ITAMP was ready, and a lot of important papers appear. I want to quote the paper that is by Marinescu and Dalgarno on long-range coefficients, which is a classic. So one thing that is important, I think, to underline is that Alex is going directly to the key problems. When he arrived to the ITPIC conference in Vienna in 1997 with Robin carrying a big luggage, they proposed to create stable molecules through photoassociation and stabilization. I think Robin will mention that in his talk. And another important thing, very early, Alex realized that the scattering length, which is a key parameter in the formation of BEC, could be extracted from photoassociation spectroscopy experiments. We also have worked on that. We were extremely fascinated that for the first time you can see in the nodes of a scattering wave function in an experiment. Photoassociation being a vertical transition between a continuum state and a bound state here. You can consider a vertical transition at a certain distance, and then photoassociation spectroscopy is scanning the nodes of the scattering wave function, which in the inner region are at low temperature, are fairly energy independent. So the quantal aspect nodes of a wave function are directly visible in a scattering experiment, which I think is something very new and fantastic. So the two first talks in the session this morning will be a photoassociation of cold atoms by Randy Hewlett and forming ultra-cold molecules by Robin Coté. In fact, in the blooming of the field of cold molecules, which has developed very quickly during the last 10 years, the workshop and conferences were extremely important. And this is what I learned from Alex. I have a tendency to isolate myself, to work quietly in my office. And in fact, we had a lot of conferences and of exchanges, and many ideas were developed due to these conferences and exchanges. So I have made a list. I think it is not exhaustive. These are ITAMP workshops, and in Europe we developed a network, and there were workshops in ITAMP, workshops in Europe that were done in parallel. So this was quoted yesterday, the first workshop on cold atom collisions. The first workshop on cold molecules, Alex had helped me to organize one in Les Houches in February 1999. Then in July, there was one in ITAMP. Then in Les Houches, we had cold molecules and BEC in March 2002, and Alex gave the final talk. Then in January 2004, when it was extremely cold, more than really unbearable temperature, John Doyle, Roman Krebs organized a conference in Les Houches. Franco Gianturco suggested that we make a special issue of the European Journal of Physics. I had the idea to make an editorial with Roman, John Doyle, and Bretislav Friedrich, and this paper is widely quoted. So for the community, it was very important that we had all these networks. There was something organized by Franco Gianturco, Jeremy Hudson, and the final workshop of our network. In July 2005, Roman Krebs, Alex, and myself organized Theory of Cold Molecules, an ITAMP workshop in Telluride. So this is where I took the picture of Alex. Alex convinced me to stop working to go for a walk in the mountain with Mireille Aimé, and here we are having dinner. And this social aspect of science, this is something I learned from Alex, and it is very important. So we identified, as early as 2000, we identified various routes to cold molecules, stark deceleration, photoassociation, and also buffer gas cooling. And among the applications of cold molecules necessitate theoretical developments. And among the new applications, many people mention quantum computing, but cold chemistry is also an important application. The theory indeed played a key role for the development of cold molecules. For instance, for buffer gas cooling, if you want to cool by collision, you must choose system where cooling collisions dominate over heating collisions. So this was an aspect that was developed in ITAMP and by Gerrit Gronenboom, in collaboration with Gerrit Gronenboom, which is very important. So the second two talks of this session after the break will be one by Roman Krem, with the full title here, on the fully uncoupled space-fixed coordinate basis representation for molecular collision in the presence of external fields. And then the second talk by Aimé Bala will be collisions and reactions in ultra-cold gases. And indeed, the future of cold molecules and cold collisions may be ultra-cold chemistry as a frontier. Will both enhanced chemical reaction be observed? Can we think of a super chemistry? I think this is something very exciting for the future, and maybe we shall discuss it during the second part of the session. So, Roman Krems organized a conference in Vancouver about cold reactions at ultra-low temperatures. And I want to thank Alex for his continuous support. Here is a dinner that we had in Calgary last year. I was extremely proud to be nominated as a member of the American Physical Society, and I am pretty sure that Alex has played a role into that. And so, as a conclusion, I want to thank Alex for the support that he gave to me and to many others through many visits in CFA, in ITAMP, through his visits in France. He was extremely supportive, especially when we developed the cold collision field. And he gave me very good advice. For instance, when I was hesitating between going to cluster physics and going to cold atom collisions, he was decisive. And so I want to thank him and open the session with the talk of Randy Hewlett.